Hi, boys and girls. It's Mrs. Lane here, and we are on Lesson 27, Variability. You're probably on page 288 and 289. However, if you've got the older version of the instruction book, you're on 278 and 279. But we're going to go ahead and start right now with this question in tan. It says, Jess knows the range of any data set is the difference between the greatest and the least values. I'm going to even underline that because that is a good definition. So Jess knows the range of any data set, and we've talked about range before. Range is the difference between the greatest and the least values. The range of a data set is a measure of the data's variability. So when we're talking about that, range just means the biggest number to the smallest number. And it lets us know how much variability there is. If we have, if our biggest number is 20 and our smallest number is 19 or even 15, gosh, there's not much variability there. But if our biggest number is 100 and our smallest number is 2, there's a lot more variability in that situation. So the range of a data set is a measure of the data set's variability, also called its spread. So that makes sense. Range and spread would mean the same thing. Is there another way to measure the spread of a data set? If so, how is it done? And that's where we're going to talk about MAD. Okay, so we know what range is. I'm going to underline it again. Range is the difference between the greatest and the least values. But what is MAD? MAD is the average of the distances of each point from the mean. So that's a little bit wordier, but we can break it apart and figure it out. So it's the average of the distances of each data point to the mean. So that means we're going to have to find the distance from each data point and see how close it is to the mean, and then we're going to average those. Okay, so here's how we find the MAD. First of all, you find the deviation or distance of each data point from the mean. I'm not even going to call it deviation. I'm going to call it distance. They're going to use deviation, but in my head every time I'm going to think distance. So if I have the data point of 10, and first off, let's start with the band. We know that the mean of the band, remember from earlier in the week, what was the mean of the band? The mean for the band was 20. And if we think, and we can look at the strings, what was the mean for the strings? You guys remember? It was like way earlier in the week. The mean for the strings was 40. Okay, now let's see if we can figure this out. So we know our mean is 20. So if I have about data of 10, a data point at 10, I know the distance from the mean is, well, 10 is actually 10 less than 20, so I write negative 10. Okay, and the absolute value of that, the absolute value of negative 10 is what, guys? 10. And we can do that for all the 10s. When I get to 20, what's the distance from 20 to the mean? Well, if the mean is 20, the distance is going to be 0. So, because 20 is not, 20 is the mean and the data value point, there's no distance in between them. They're the same. And the absolute value of that is 0. Take a look at 60. There was a data point of 60. We know the mean is 20. How far away is 60 from 20? 40. And the absolute value of 40 is 40. So do you see how that works? Once I'm done with that, I add up all of these numbers. Okay? So here's how far they are away from the mean. Here's their absolute value. Then I add them up. And I'm going to start from the bottom just to make it simpler. So 40 plus 20 is 60. Plus 0, 0. 10 is 70, 80, 90, 100, 110, 120. So I come up with 120. And then they divide it by 10. Why did they divide it by 10? Well, because there's 10 different data points. So divide by 10, and we come up with 12. So our MAD score would be 12. And the MAD of 12 means that on average, every data point is $12 away from the mean. So on average, every data point is $12 away from 20. I hope that didn't confuse you. I hope you're still with me. Let's take a look at the strings. Okay, we've got these strings over here, and we said from earlier in the week that the mean, the average was $40. Okay, and here are all of our data points. So the first one was 0. What's the distance of 0 to 40? Well, it's -40. But the absolute value of -40 is 40. Then we go to 10. What's the distance of 10 from 40? Well, 10 is still 30 points below 40. So -30, and our absolute value would be 30. Ooh, then we get up into 40. How far is 40 away from 40? What's the distance or deviation from the mean? Well, 40 is the same as 40. So it's 0. Let's try like this one down on the bottom. 60. There was a data point of 60. How far away is 60 from our mean of 40? Well, 60 is 20 points greater. So our distance is 20, and the absolute value of 20 is 20. I hope that it makes sense to you guys. I know we're going kind of quickly. So then you come up with all of these absolute values. You add them up, and you get 140. And we divide by 10 again, because there are 10 separate data points. And we get our math score of 14. So on average, every data point is $14 away from the mean. Okay, move forward with me, boys and girls, to the next page, page 289 or 279, depending on which book you have. Okay, boys and girls, we've moved on to page 289 or 279, and we're going to answer questions 15 through 18. So let's take a look at 15. 15 says, look at the tables and model it. Okay, and it wants to know, first of all, what does a negative deviation mean? And remember, we said deviation was the same as distance. So let's take a look. So with the band, for any of these scores where there's a negative, what does that negative mean? Well, that means that that particular data value, this -10, is 10 less than the mean. So we're going to write, what does a negative deviation mean? It means the data value is less than the mean. Okay, moving on to the second part of that question. What does a positive deviation mean? Well, a positive deviation means that data value is greater than the mean. Just don't give me enough room. I write too big. Okay, let's go on to the next one. What does zero deviation mean? Well, if you've got a zero deviation, such as, let's take a look at some of these right here. You've got 20 had zero deviation. The reason 20 had zero deviation from the mean, or 20 was zero distance from the mean, is because the mean was 20. So what does zero deviation mean? The data value is equal to the mean, or the same as the mean. Either will work. All right, moving on to our next one. 16. Why do you take the absolute value of the deviation? So we came up with all of these numbers, and some of them were negative, some of them were positive. Why did we have to take the absolute value? We had to take the absolute value because distance cannot be negative. Like this -10, we had to take the absolute value of 10 because I can't ask you to walk -10 miles. You can walk 10 miles, but you can't walk -10 miles. So distance cannot be negative. The direction of the data point from the mean doesn't really matter. Okay? So it doesn't matter if it's which way it goes from the mean. It just matters how far away it is from the mean. Let's take a look at number 17. And 17 says, compare the band and strings MAD values. Okay, so if we looked back to this, we found that the band had a MAD value of $12 and the strings had a MAD value of $14. So keep that in mind. Strings are 14, band is 12. Which data set had slightly less variability in data points from the mean? Explain how you know. Well, we know that the band had less variability because the MAD score for the band data is less than the MAD score for the string data. 12 is less than 14, so there's less variability with the band. So write the sentence, the band data is less variable, or are less variable. The band data the MAD for band is less than the MAD for the strings. All right, and we're going to move on to question number 18. Question number 18 asks, which indicates the greater degree of variability in a data set? A high MAD value or a low MAD value? What do you think? Think back to the question that we just answered. I hope you said a high MAD value, because a high MAD value represents greater variability because it means a greater average distance away from the mean. Oops, I'm going to start with a high MAD value. Is going to indicate, or you can put represents greater variability. Because it means it has a greater average distance from the mean. All right, boys and girls, thanks for staying with me. Go ahead and try 19 on your own. I know you'll do well with it. And then go ahead and do your PPS pages. All right, thanks guys. Bye.